In this video, we take a look at how we can use z-scores to construct any percent confidence interval. The z-score measures how many standard deviations a statistic is away from the proportion. If we were talking quantitative data, we would say it's a measure of how many standard deviations a statistic is away from the mean. Since this is categorical data, we think of the proportion as the center of our normal distribution. Our 68, 95, 99.7% rule, also known as the empirical rule, uses approximations of z-scores. So mathematicians can actually calculate accurate z-scores by measuring the area under the normal distribution curve using calculus or a computer to numerically calculate. We're going to let the computer do the numerical calculations for us. With calculus, this can even be a bit of a tedious calculation. So we like to outsource calculating areas to a computer. So because we can calculate by measuring the area, we can find the z-score for any percent confidence we know. So using what we know about the 68, 95, 99.7% rule, about how many standard deviations would you expect for a 90% confidence interval? So we know, okay, 90% is going to be between 1 and 2 standard deviations because 1 standard deviation corresponds with 68% confidence. And 2 standard deviations correspond with 95% confidence, so we expect 90% should be somewhere in the middle. So we're going to head into StatCrunch and go into the normal calculator and find exactly this. So in StatCrunch, remember you're going to choose Stat, Calculators, and then Normal. I'm going to open StatCrunch. You can open a blank window or use a window you have already opened. Then we're going to head to Stat, Calculators, Normal. By default, we have 0 as our center, our mean or our proportion, and then a standard deviation 1. So we're going to leave that. And then we want to know where is the middle 90%. So I'm going to go to between. So right now, if I'm down 1 standard deviation and up 1 standard deviation, I've got right about 68% in there. I'm going to change this area, the bottom right box here, to 90%, which is 0.90 as a decimal. And when I hit compute, I see that corresponds with 1.6449 standard deviations on the positive side. We just get the symmetric negative value on the lower side. So we say our z-score would be plus or minus 1.6449. Usually we just write down the positive value and know that you'd add or subtract to find your interval. And so that rounds to 1.645. So now we want to know about how many standard deviations would you expect for a 99% confidence interval. Well, before we head into StatCrunch, we know 99% confidence is between 2 and 3 standard deviations. 3 standard deviations is 99.7% confidence, so we expect a value a little bit less than 3 standard deviations. So let's head back into StatCrunch, and we'll change our 0.90 for 0.99 so that we get 99% in the middle of our normal distribution. And we're seeing the middle values because I've got between clicked here. If I was on standard, it would just give me a lower or an upper value. So we see here 99% confidence corresponds to 2.5758 standard deviations, and we see the symmetric value on the negative side. So we could say our z is going to be plus or minus 2.5758, or we can round this to 2.576. When you're doing calculations, you'll see these rounded to 2 or 3 decimal places. It's not going to make much of a difference calculation-wise whether you use 2 or 3 decimal places, so either way is okay. So we see down here a sketch of the 90% confidence interval with that 90% in the middle. So the z-score here is rounded. They put the 1.65. So again, whether you put 1.65 or 1.645, you're not going to see a whole lot of difference in your estimates. Within 2 or 3 decimal places, you'll get the same calculations. So with 90% confidence, what percent is in each of the tails? So we see, since we know everything has that up to 100%, we must have 5% or 0.05 in each tail. So you can think about the wider the confidence, the less room for error in the tails. And so here's a z-table with the exact z-score values. So the z is often called the critical value z. Sometimes a little subscript c is put down here. So we know for 90% confidence, we can use 1.645. For 95% confidence, we've been using 2, but if we go check exactly in StatCrunch, a more exact measurement would be 1.96. So for the purposes of our class, you can keep on using 2 as our corresponding z-score for 95% confidence, or you're welcome to use 1.96. I use them interchangeably depending on how precise I want to be. And then 99% corresponds with 2.576 standard deviations, or if we're working with a sampling distribution, we'll use standard errors. Here's some data from the survey of 320 randomly selected students currently enrolled in statistics in California. These students were asked what were their transfer plans, and we saw 178 planned to go to a CSU, a California State University. 93 planned to go to a UC, University of California. 17 planned to go to a private college, and 32 are not transferring. They're going to get a local degree and go get some sort of job or continue in some other sort of training. We do a quick check to make sure there's at least 10 in each group so that the normal approximation is appropriate for our calculations, and it is. So now we want to use these values to calculate a 90% confidence interval for the proportion of statistics students at California community colleges who are planning to transfer to a UC or to a CSU. So we're going to calculate the sample proportion p hat first and then interpret the meaning with a sentence once we find our interval. So p hat is the count of students who plan to transfer to CSU out of the total surveyed. So that's 178 over 320. As a decimal, that is 0.5563. Our standard error follows the same formula as the standard deviation for proportions, except we're using p hat here. So 0.5563 is here for our sample proportion p hat. And then 1 minus that 0.5563 is the 0.4437. So we're going to multiply those and divide by 320 our sample size, and then finish up our calculation with the square root. So I did that on my calculator. If you're calculating on your cell phone, you might have to rotate your cell phone to get the square root symbol. I have to do that on mine. It doesn't show up on the simple calculator. So my result for the standard error is 0.0278. Now remember, this is an estimated standard error because we're using the sample data, the sample proportion. So now we're going to use the z critical value 1.645 because I want to be 90% confident. So we are going to start with our sample proportion p hat and then add and subtract 1.645 times the standard error. So plugging in the number values here, I have 0.5563 plus or minus 1.645 times 0.0278. I multiply the 1.645 times the 0.0278 first to get the 0.0457. And then we're going to add and subtract 0.5563 plus or minus the 0.0457 to find our limits. So our lower limit, you could also call it the lower bound, is going to be 0.5106 when I subtract. And my upper limit when I do the addition is 0.602. So now I need to write a summary sentence pulling together all this information. So I said we are 90% confident in our calculations that between 0.5106 and 0.602 of statistics students at California community colleges are planning to transfer to a CSU. We want to check to make sure that in our sentence we had how percent confident we were, and that we gave the range of values from the lower limit to the upper limit, and that we were predicting what the whole population. So in this case, our whole population was students at all of the California community colleges. So our summary sentence hit all of that criteria. Now in part E, we are going to construct a 99% confidence interval. So for 99% confidence interval, we are using our Z, or our critical value, of 2.576. So our formula here is going to be the sample proportion p hat plus or minus the 2.576 times the standard error. So we get 0.5563 plus or minus 2.576 times 0.0278. We do the multiplication of the 2.576 times 0.0278 first, and that gives us 0.0716. And then we do our subtraction to find the lower limit and our addition to find the upper limit. So When we subtract, we get our lower limit of 0.4847. And when we add, we get our upper limit of 0.6279. So now we want to pull this all together in our summary sentence. So the way I constructed this summary sentence is a little bit different to show you a different way of writing a summary to interpret the meaning, but we still are getting the main ideas across, just with slightly different language. So I said here, with 99% confidence in our calculations, we predict between 48.47% to 62.79% of statistics students at California community colleges are planning to transfer to a CSU. So the differences here are that I use percents instead of decimals to convey my range of values, and then I explain my 99% as how confident we are in our calculation. That's the same thing as saying that we are 99% confident. So you somehow want to explain that that's how confident or how sure you are that you calculated correctly or that you captured the true population value. And then our prediction here is about the whole population, all the California community college students. And then there's a note that you could look up any z-score using the normal calculator or at the z-table. I think the z-table is in the chapter 4 notes. All right,